possible. Okay, let's start with number 2. Find domain and range where the function f of x is square root of 1 minus 2x. Okay, first for the domain, whenever you see a square root, you're not allowed to have a negative number inside the square root. It has to be 0 or positive. That's how you can figure out the domain. 1, 2x, you divide by 2. That means x can be 1/2 and less, but not over. In other words, the domain, if you write in terms of the interval notation, it ends at 1/2. It can be anything less than 1/2, even negative numbers. So, see, if x is, for example, -1, there's no problem in evaluating this function because 1 minus 2 times -1, that gives you 1 plus 2, which is square root of 3. That's perfectly fine, right? So that's why anything in here is okay. You need 1 minus 2x to be 0 positive. For that to happen, x can be negative, or if it's positive, it can be up to 1/2. Okay, that's what we see. All right. Now another thing that you have to do for the range. Well, when x is equal to 1/2, what do you get for y? If you say y is this, what's the value? 1/2 times 2 is 1. 1 minus 1 is 0. Square root of 0 is 0. Okay. Can square root produce negative numbers? Never. So 0 is the least it can produce. So, and 0 is produced, right? And then let's see, how big can this go? Well, if x is a huge negative number, then this can be very big, right? So think of x as like -1 million. Then that's like positive 2 million because of this negative. And there's one more, so it's 2,000,001 square root. That's still a huge number if you take a square root, right? So square root of 2,000,001 is like 1,400 something. Okay, so that's pretty big. And you can go more and more. You can make x to be 1 trillion and so on. Therefore, y doesn't have any limit. So this is your minimum, and therefore when you take the range starts at 0 and it can go up to infinity. Now for b, g of x equals to 3x minus 1 over x plus 2. What's the domain? This time, if you have a fraction, you're not allowed to have a 0. So x plus 2 cannot be 0. And if you subtract 2 both sides, you see that x equal to -2 is the problematic value. If you plug in x equal to -2, the bottom becomes 0, and therefore you get an undefined value. Therefore, x should not be -2, and that's your domain. Now, written in terms of interval notation, it's everything up to -2. You skip the -2, you can still go to infinity, and you get 2 intervals, right? The way you look at this is, just think about this. You have -2, and anything on the number line is a allowed value for the domain. You can plug it in here, except -2. So if you take the -2 out, how many intervals do you see? One on the left, another on the right, right? So the left interval looks like that, the right interval looks like that, and you're putting it as unions. Okay? Now for the range, you need to know the graph of this thing. Okay, so So there are many ways to graph this. You can find the vertical asymptote, horizontal asymptote, the x-intercept, y-intercept. You can find all those things. Let me skip a little bit. If you for the horizontal asymptote, you take the ratio between the coefficient of x. If they have the same power, this is x to the first power, x to the first power, right? In that case, the coefficient of the highest orders become the horizontal asymptote, which is, in this case, is y equal to 3. So you get y equal to 3 as a horizontal line, and that should be drawn as a dot when you draw this graph, okay? For the vertical asymptote, you set the denominator equal to 0, so you get x equal to -2 as the vertical asymptote. Now for the y-intercept, you plug in 0 for x, so you get 0, comma, -1/2 is your y-intercept. And for x-intercept, you set the entire thing equal to 0, and if you solve that, you get 1/3, comma, 0. Those are the critical values in order to graph this. So let's try to graph it. So at x equals to 3, you have a vertical asymptote. At x equal to -2, you have a horizontal asymptote at here 3, and at -2 you have a vertical asymptote. Y-intercept is somewhere here. X-intercept is somewhere here. So you need a graph that would pass through these 2 points while getting close to this horizontal asymptote as you go right, and when you get closer to -2, it has to go closer to this vertical asymptote. Therefore, the only reasonable choice seems to be this one. And for the cases where you have only first powers, there's another graph that behaves like that. Okay, so if you do linear polynomial divided by linear polynomial, you always get a hyperbola, and because you know one side looks like that, in order to complete the hyperbola, it should be the other one should look like that. Okay, that's only if it's both first power. If it's x squared or more, it's more complicated. All right, looking at this, what do you see? Does this function produce all values as y? It skips 1, right? Which one does it skip? 3 is the one that it skips. So therefore, the range R is equal to -infinity to 3 union 3, comma, infinity.
Can we just find the horizontal asymptote? That's sketchy.
Oh yeah. So if you are,
It's always the horizontal.
if you know this rational function as well, then you probably, without even graphing this, you probably know already that if you have linear divided by linear, then it's just going to produce every value except the horizontal asymptote. If you know that, you can skip all this process and then just say that as the answer. Thank you for that comment.